Started. Yeah.
Yeah. So, hi everyone. Very good morning and welcome to MuleSoft Mysore Meetup group. Thank you all for taking your time and joining today's session. Today we have our speaker Prithvish here who is going to talk about M units, where he will show like different scenarios as well, like how we can write M units for loops and choices and so on. So before we start this session will be recorded for your future reference, so you can check out the content in our YouTube channel or Mysore Meetup group page. And this session is meant for learning purpose only, so feel free to unmute yourself and ask questions, or you can also put your question in the chat box. Before we start, let me introduce you all to the organizer of Mysore Meetup group. So we have Shubham and Giridhar here. They are Mules of Meetup leader and Mules of mentor and Mules of ambassador. So Shubham is currently working with Bilinium as an integration developer, and we have Giridhar here who is currently working with Hashdin as a technology architect. And here I am, Priya Shah. I'm currently working with LTI Mindtree as a senior software specialist. So feel free to reach out to us in case if you want to suggest any topic or you want to be a speaker. Now it's time to know your speaker. So Prithvish, you can introduce yourself and then we can start up with the session.
Hey, hi. You guys can hear me, right?
Yes.
Okay. Hi, everyone. I'm Pritish. So I'm an integration developer working at Hashton by Deloitte. Uh, I've been working with MuleSoft for almost over 4 years, and I have a total of almost 5 years worth of experience. I have worked with different scenarios, ranging all sorts of integration patterns and everything. So yeah, there's that. So should I carry on with the next slide?
Yeah,
Yeah.
yeah, Prithvish, you can start.
Okay. So for today, I will be demonstrating the MUnit capabilities of MuleSoft. Not the basic ones, but I will be covering certain special cases of MUnits which we face in uncertain occasions. Uh, Rather than writing multiple MUnits, redundant cases, and also sometimes in cases of asynchronous implementations, we are left a little confused as to how we can build and build MUnits so that we can keep up with the code coverage. So with that, I will first start off with what is MUnits and how does it help, right? So MUnits, okay. So basically, it is like a testing framework which helps us, automate APIs, integrations, whatever that we build using MuleSoft. So the point is that it is kind of like a white box testing framework. By white box, I mean that it allows us to go to the absolute low level of each processor that we have within a flow or a subflow, or yeah. So and we can actually try to understand we can understand what is the behavior of each of these units and come up with test cases as and when required. Okay. There are basically three parts of an MUnit test. One is the behavior, which kind of sets the preconditions to however you want to execute the test logic. Like, suppose you want to test a flow which expects some sort of a payload to it, okay, some sort of a unique request structure that will help it operate as expected. And then in behavior you simply set that particular event how you want, maybe attributes, maybe the payload or certain variables. You set it there in that space, and that will serve as a precursor to the actual test. Next is the execution. Of course, you want to reference that flow or subflow that you want to test in that case. Okay, it need not be like a flow always, it can be a subflow also. Um, whatever precondition you want to implement on that flow or that subflow should be referenced in the execution part. All right. The last scope is the validation. Validation is where when the execution, you know, has completed, you need to know what are, if the outcomes are as expected or not. Okay. Even in case of error scenarios, you want to check what is the error message. This is the place where you need to do. There are these assert operations and verify operations, uh, by which you can actually test whether the response status code or the response payload, these match according to that particular test case that you're testing or not. All right. So MUnit basically helps us perform all of these things. Um, at first, it might seem like it's like a white box testing, plain white box testing framework, but it also and it also helps in unit testing for all developers, because developers at the end of the day have to build these things. Um, but what it also does is it also helps us. We can implement different test cases for functional testing as well. It need not just be to keep up with the code coverage requirements as a part of the compliance. Okay, so a lot of these capabilities are provided by MUnit. So as I was explaining, on the left hand side of the screen, the first one, okay, this is kind of like what a basic MUnit test looks like. You set the payload or set event however you want. There are these operations listed in both of these screenshots on the other side, which you can use to perform, set the event and also validation. In execution, you can start off with a flow reference. You can, even if suppose you are referencing a flow which has an HTTP listener, right? So MUnit has the capability that you can also provide a requester. Okay, if you provide a HTTP requester and provide the localhost path or however you have kept it there, okay, um, and put it here in the request, this request will call that listener of your main flow and start the execution. And you can simply set the payload here. That payload will be used as the request payload. So these are a few neat ways of how you can, keep tweaking MUnits to cater to your, testing needs. So these are some of the operations, and these are some of the both of these are operations. You have to understand that some of these are validation cases, like all the asserts, okay, and all of these mock, then spy. These are usually behavioral operations. Asserts are all validation operations. Okay, you can also have different routers and scopes also within NUnits. Okay. Next. Okay, what I keep talking about, code coverage. Okay, point is that what do I mean by it, right? So, code coverage is basically like, suppose you're testing something, right? A particular test case. It can it this is not necessarily to just MuleSoft. It can be across all major I mean languages that you use to, frameworks and languages that you use to develop solutions. Basically, a test case should ideally cover most of the uh, processors that are there, okay, that you've pulled in to build your solution, right? um, that is basically what is meant by code coverage. Like when you run an MUnit, it should cover all of the processors that is there. um, it helps in, like in the unit testing level, and you can understand where something, you can actually mimic some of the operations inside that particular flow. Try to understand what happens before and what happens after, okay, in that particular flow. Okay. um, and finally, when a whole MUnit suite is run, you get a code coverage report, right? What does that report say? It tells us that across all the entire code, all of the test cases that were run using MUnits, were they able to cover all of the processors or not, right? And that is the code coverage percentage that comes into the picture. Um, Total number of processors is there, and the number of processors that you could actually hit using all of your units. Okay, so it's like number of processors hit across all of the test suits divided by the total number of processors is what comes as the code coverage, right? Now, ideally, what it's like an understood standard that 80% is what we should stick to, right? um yeah, anything less than 80%, or any number lesser, okay, tells us what, that do we need to add more tests, okay, so that all of the scenarios are covered. It also says that do we even have enough tests, right, to cover all? Like, suppose we have a choice router. Are we covering all of the branches of the choice router? Um, Kind of like that. Even when it comes to error handling, like all of those error handlers that we have, the different namespaces that we cover, are we covering all of those? Okay, these are simple questions, but code coverage doesn't necessarily mean that you are creating a foolproof. Even if you hit like 100% code coverage, that doesn't at all mean that it's a foolproof test suite that you've built, because code coverage can be done in two ways. Like, one is to just to meet the compliance, right, just to ensure like you write whatever test cases that covers the maximum number of processors. Um, another thing would be, which is the ideal way to go, would be to perform functional testing, at the unit testing level. Why is that necessary? Is in compliance mode, if you go, you will just be creating test cases catering to your needs, but to fulfill the compliance. But if you do functional test cases, I understand you'll have to write quite a few M units just to, cater to the functional requirements, like business rules, checking whether particular cases, have been covered or not. Okay. These will have redundant, processors being called, right? And these will not help you in the quickest way of performing code coverage, but it will ensure that you have a foolproof uh, you know uh, test suite, which ensures that the quality of your code is solid, and I mean, no unidentified bugs are remaining. Okay, so there's a give and take, and I think developers have to decide how much they want to prioritize, because at the end of the day, you can't also like give up on code coverage. Also, from the push from 80% to 100%, okay, it can be a very costly operation. It can be very time consuming to push from 80% to 100%, because there might be certain very niche cases for which a particular code block will be I mean, triggered, and to create a test case just to cater to those particular niche cases can be quite time consuming, right? So these are some of the features, caveats of code coverage. Yeah. All right. Moving on. uh, so I will talk about parameterizing munits. Okay. So we build usually normal munits, we keep building and everything, right? But suppose we are talking about choice blocks, right? So suppose there are four choice blocks, like okay, in your solution, do you now build four different test cases, in munit tests to I mean, test each of those branches? No, I mean, you can do that, but another very neat way of doing that is using the concept of parameterizing munits. Okay. Now, there are two ways of parameterizing munits. Okay. So, for complicated scenarios, as I said, in many cases where you see that there are branches, or there are, I mean, at one point of time, only one branch will be taken. It might not be choice, it can be API kits also. Many different ways. It can be testing error handlers also. Like, many different ways you can uh, parameterize the munits so that you can uh, come up with like one test case which takes care of all of the branches. Okay, there are two different ways of approaching parameterizing in units. Okay, one is the YAML based parameterizing. Okay, uh, this YAML based file, what we do here is we 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 kind of try to identify. I've given a very simple case over here, that is trying to test the input and output of one particular test scenario. So now for each of those branches, I have one input, one output, right? And suppose there are three actual branches and one default branch. Okay. So how do you now create the file? Okay. So on the left hand side over here, see, for each of those branches, the first parent nodes are not exactly important. These basically differentiate each of these input output pairs. Okay. And once you create this file, this is suppose the input that you're expecting. This is suppose the output that you're expecting. Now, what do? You go to the munit case that you've built. Okay. Go to the go to the configuration and select this file name as the parameterization file. Okay. Now, when you run the munit case, what it will do is it will divide each of these into four different sections in four different sub cases, sort of. Okay. In each case, it will use the input and it will use the output. In the code, you will use not like dollar curly braces input, dollar curly braces output. That itself will do the trick. Okay. You don't have to write aus.input or aus.output. You simply have to write $.input, $.output. What it will do is it will take this file here, it will parse it, divide it into, it will be sort of like a table with uh, two columns, input and output, and these will be the rows inside it. So in the first go, it will check for input AU, output Commonwealth. Next round, it will check New Zealand details. Third, Indian details, and then finally in the default case, it will try to do this. Okay, it will run four times with each unique set of these input output pairs. Okay. And this file must be saved in the test resources directory of your project in order for it to be available. Okay. The next is the Mule configuration base. So in the place where I said that you can provide the reference of that file, rather than providing the reference of that file, you can create your own parameterizations. How do you do that? This choice scope is like the parent node. Okay, loop scope and choice scope. Again, it's the same thing. You create the parent node like this, and in the parameters inside it, you put the input and output. I have simply referenced the files. Okay, wherever it's stored, either a string or a file, what you want, whatever you want, you can put those values in, and then Mule will treat them individually as uh, parameterized items, right? Basically, what are you doing? You're automating the input and output to a particular test so that you don't have to keep on building new cases and running them, right? Okay. In this case, what it'll do, it'll run twice because there are two parent nodes over here. Okay. Right. Now I will talk about special cases in munits. Okay. I won't just talk about the different, you know, special cases there are. I will also talk about the difficulties that I faced when I came up with this POC. Okay, I will talk about all the, the loopholes and the pitfalls there are, how you can come around it so that developers who are trying to explore munits don't have to spend a lot of time trying to figure out what is actually going wrong. Okay, I will kind of quickly go through this place because I want to go to the hands-on as quickly as possible because that is what it will help us. So suppose we have a choice router here, right? The use case is like this, that you are getting a query parameter from a particular request from before. Based on that query parameter, you will set the request structure. Okay, then call a particular API, which is, behind this flow reference, and you're setting the response, right? Your job will be to check based on when my query parameter is something, what is my response, right? If it's new NZ, I will expect the response to be details about New Zealand, right? So this is, kind of like the use case that we will be working on for the choice router. Okay. So what do we do? Again, you see, we have this parameterized YAML file, okay, for the input and output. In the input, we will basically be choosing the query parameter, right? The query parameter is the input here, and the output will be the asserting the payload, final payload, right? So you create this, then you create this YAML file. After that, you create this test flow, right? Now, in the test flow, what do? You have that flow that I told you about, right? This one, this particular flow. You reference that flow here in the execution. And in the behavior, what do? You set the event. How do you set the event? As I said, we kind of use the query parameter as the input, right? On the basis of the query parameter, our output will keep changing. So what do? We go here, and in the query parameter, we set the mule colon p input, right? So what it'll do inside query parameters, q param is one field. Inside this, au, nz, in, and default will get stored. Not at the same time, separately, okay? Because these will be parsed into 4 different cases. Okay, next, what do? In assert equals, what are we testing? We are testing the payload, the final payload that we have, and we assign the expected value as mule colon p output, which is the next one. Okay, so for each key value pair, like since only the first 3 lines or the first two per case will be taken. So for AU, I'm expecting Commonwealth of Australia, right? For NZ, it's New Zealand. This is what it will be done in this assert equals. And finally, you just click on the test flow. There will be a global config over there, and the munit configuration will be there. And there, just provide the parameterization file with the file name that is there. Okay, and you're good to go. Okay, you will find that 4 cases are created, and all of them are successful. Um, Next is something that I want to talk about is the second way of parameterizing, which is using the configuration. So now here I have 2 choices. I think based on the path, I'm differentiating between 2 operations. So if the path is, suppose, one particular item, we will go for the choice router. Otherwise, we'll go for the loop scope. Again, 2 cases. We want to test these. How do we proceed? Okay. So we first come up with the request and responses that we want. So for the choice request, the path we are expecting is this one. And for the loop request, the path that we are expecting is this one. If the choice router is like this, the response I'm expecting is Commonwealth of Australia. If the path is loop scope, okay, or it's the loop one, we are expecting a response like this, okay, an array of country details, right? Next, what do? We built the test suite, right? We set the payload, right? Because I think in some cases we have a post call over here, I think. So in the raw request path, I'm passing the payload, okay, and this will be basically the payloads over here. And in the query params, I'm passing AU, because in the choice router, I have kept a query param, which is why I'm passing AU over here. So in this case, this is how I'm setting the event, you understand, just to cater to my needs, okay? Because my choice, the path of the choice router has a query parameter. So I will set an event where it matches my real world scenario, okay? Um, Okay, now here we right click on this, or not right click, we go to the global config of this test suite, and we set up the parameterization. No more file based. We are choosing choice scope, loop scope. In the input, there's in both will have an input and an output. In the choice param, the input is this, okay, and the output is this, okay. Same for the loop scope, okay. What did we do here? We in the set payload, you see, I set the input, right? I set the input. So in both cases, the input will be taken as a part of the payload, okay. And finally, in the assert equals is the output, whatever output I'm expecting. What have I put here? Dollar output, right? So the output payload will match the dollar output. What are the outputs? In first is the choice response DWL, this one. In the second one, it's the choice param loop response, this one. Okay, two ways of parameterizing, right? Okay. Next, this is the for each scope. Okay, now the use case is like this in for each. Um, let's concentrate on the first flow first. What do? We set the request parameter to call a particular API, which probably fetches me details of small details of at least 100 countries, right? Next, what do? We iterate over those 100 countries, and we selectively, and no, not selectively, for each country, we call another API to fetch more details of that country. Okay. And I think then we kind of we append those details, right? So this flow reference comes here. Okay. Again, we are fetching the exact country details. And in this append details, what we are doing is whatever we get, we are trying to create a list of those country details. Like I think we are fetching country name, capital, and region. We are creating an array of those uh, things. Okay. So this is the use case. Now, if I proceed, see, it's a for loop. The usual way of testing for each is what? You go back to this for loop. This is the subflow, right? You just create an munit inside this flow. Then what happens? You will not be able to test it from a high level perspective. What you're doing, you will only be able to test, suppose when one unique case is like that, okay. Like the nth iteration, you'll be able to test whether it's the first one, fifth one, sixth one iteration you'll be able to test, right? So how do you do it? And also, for every time that you'll be testing, your input will be fixed, right? You will not be able to change it and see based on the iteration count, how is my payload changing? How is my output for each case changing? Okay, because you want more control over the testing. You don't want to just treat it like a black box, right? Also, at the same time, you don't want to treat it like you just want to check one iteration. Okay, you want to do like you want to see the before and after, but at the same time, you want to see dynamically how the flow is behaving with each iteration, right? Changing the request on request by request, I mean changing the before and after on the basis of each iteration. How do you do that? So what do? You have a mock here, okay. And what are we mocking is this fetch country details, okay. And what do we do here is we don't provide, so there is a particular parameter in mock, okay. And what does that parameter do? When you are mocking, do something, okay, rather than setting a payload or something, you can also ask it that when this particular processor comes, you go to this flow, okay, in the test suite. So what happens is, now I'll create a choice block. And in the choice block, since we are inside that for each scope, we have access to the counter variable, right? Because for each loop has a variable counter only inside that scope, right? So what do? Here is where the interesting part comes is you can assign it. Suppose you have four, that you want to test like the first three or the first four. So what do? You put the counter. When counter is 1, you set a particular payload. Okay. When counter 2 comes, you set a particular payload, right? In this way, you are sending dynamic request. Okay. Like you're mocking that API. Okay. And you're not just giving the same request every time. With each iteration, you're giving the mock a different payload. Okay, so that finally when you have this assert equals and you are testing against a particular payload that you expect that should be there, okay, on the lower right hand corner over here, when you expect this payload, what you are doing is you're giving a dynamic request and trying to check whether those dynamic requests merge together to form your expected response or not. Okay, which gives you more power rather than this being just a simple, random case. Okay, like you could have given like a static payload and it will always be the same, the output. But here you are giving setting the payload uniquely on the basis of, like, suppose in the first iteration that API sends this payload, so you set it here. Okay, and in the second iteration the payload sends another particular payload, so you set it in the counter 2 and check the output. Okay, so this is how you can get more control over for each scopes. Okay, uh, moving on, I added another capability of APIKit router. Okay, this is the happy path. APIKit router again is like a choice router. Okay, so it's kind of like the same thing only. What you can easily do is you can right click on APIKit and create a test suite. And majorly this will be created. Some things I changed here and there. Okay, um, and what you can do is you can set the payload, set the event, and assert that. So in assert that, basically you'll have to assert HTTP status is equal to 200 or not. So in assert that, the expected will be 200, and the actual you'll put vars.http status, and it will match the status code. Same for assert equals. You can provide actual as payload, um, inside expected, provide the reference of the file or whatever string that you have directly inline, or reference the file however you want, you can provide, and that is what it will do. In the API kit, basically I have two different resources, resource 1 and resource 2. Resource 1 is a post call, resource 2 is a get call, and this is how it performs. All right, I will now move on to hands-on. Okay, let me know when you can see my studio. All right, can you see my studio, guys?
Yes.
Okay, right. So, okay, right. Let me walk you guys through some of the actual scenarios. I will deploy this code first to show you how this code behaves. Okay. So this API kit router, I had created a very simple RAML. Okay. Um, with just resource 1 and resource 2, one get and one post, right? That is there. Okay, and the usual API kit errors are over here. Okay, and these are the APIs over there. This is that second case of choice router, as I said, the configuration based implementation, right? Um, and finally, there is one bonus scenario with batches, which I'll brush over towards the end. Okay. Um, inside common, I have that main file-based choice parameterization, and this is the loop scope. Okay. Okay. I have created this choice router nzsn. Don't think this is ready yet. One second. So yeah, we're ready. Yeah. So you sent NZ and you got New Zealand, right? This is what the choice router does on the basis of the query parameter that you're sending, you will get that particular country name as a response, right? This is one of the uses. uh, in loop scope, I have hard coded not the response, but whatever I get, I've hard coded like just the first three. So if you run this, what it'll do, it will keep fetching each country and it will concatenate, append them into one array and give it back to you. Okay. In APIKit router, the post call, what I'm doing, I'm simply sending a payload and I'm attaching there a success field inside it, and another one is the get call, which will simply send you back that previous response. Okay, it'll mirror you back the previous response. And then there is the batch process. Okay, so this is the use case that I was actually talking about that I had built. Now I will go to the first choice suit here. Okay, now set event, this is the first one with the file based uh, parameterization. See, here there will be something called parameterization file.yaml. Here you will have to, in the drop down, if you put under test resources those YAML files, you will be able to get the parameterization files. So all of them will be listed here. You choose which the one you need, and this will be the one that you actually expected. Okay, nothing will be filled up here. Actually, you can also add things here. Okay, you can overload this YAML one and you can actually create your own parameterizations here. I haven't showcased that, but it's nothing really different. It will, both of them operate on the same level. So yeah, and in case you have the same parameter in both of these file and here, it will, this one will override the one in the file. Okay. So this one is that hold on. Okay, in set event, yeah, this is fairly simple. I've just set up the attributes here. Okay, as I showed, since it was dependent upon the query parameter, the output will be on the basis of the query parameter. So I set the query parameter here. This is the flow reference to that particular flow. I can show you that flow as well. Um, this is that flow we were talking about, right? Let's go back, and assert equals does what? It will simply check the actual is payload and what is expected is the output. Okay, this is how this one works. Next, I'll go for the choice router on the basis of um parameterization in the configuration. Okay, so sorry, what happened here? See, you can create the parent nodes here, and inside each of these parent nodes, you create these parameter names, input output, and in the loop scope you also put the parameter name as input output. You can perform an edit here and check out what I've kept here. I've simply done a read URL to read those particular files. Okay, cancel. Let me go back. I had something to say here actually. Set payload input. Yes. Now I'll talk about one problem that I had faced here. Okay. Only developers will face issues like these. Okay. So in the set event attributes, what am I sending? I'm sending the path, right? The raw request path. Basically, the difference that we are making. Are we going for the choice router or are we going for the loop scope, right? So two different paths based on that. So in the raw request path, I'm passing payload. Why am I passing payload? I'm setting the payload here, and inside this payload, I'm setting up the parameterized value here. Why? If you put mule colon colon p input here directly, okay, here, if you put dollar input here directly, what will happen? It will simply take that read URL command as a stringified, thing. Okay, it will not parse it as a data weave command. As a result, what was happening? It was constantly failing. So it's best that you set it as a payload here. Here, that thing will get parsed, and your payload will actually contain the file content and not the read URL command. Okay, which is why I've set the payload here. Right. These are some of one of the issues that I face, and I had to it's such a simple solution, and yet I had to spend at least half an hour trying to understand what was going wrong and why was $.input not coming as was expected in the set event. Okay. I will move on to the loop suit, the same one as I said. What am I mocking here? I'm mocking that flow reference to that call to that external API. Okay. And what am I doing for each case? Okay. For each case, when it's iteration one, I'm setting a particular payload. When it's iteration two, I'm setting a particular payload. Now I'll show you the payloads here. Okay. It should be under examples. Okay. Yeah. This is the first iteration payload. Okay. This is the details of Algeria. Okay. All the details. Okay. This is it's like how my API will actually respond. Okay. For the first iteration, for the second iteration. Okay. And I've stored them. And for each of those iteration, when counter is one, I'm setting the iteration one actual payload. Okay. And once they're done, what it will do is this will try to check the expected response. So on the basis of all of these, okay, dynamic requests, I'm trying to check the expected response. So it's Algiers, Angola, and all of these countries together in one array, and we are trying to match it whether it's working or not. Okay. Um. Okay. Choice router done. API kit. Okay. Again, in API kit, what am I setting? I'll show the post call because the get call is very simple because there's no parameters. Also, you just get the call and check whether it's 200 okay or not, and the response is as expected or not. But in the post call, you need to set a payload, and that payload, because the post call you expect a body. So I'm passing this payload here, and in this request, see, in some cases I've used flow references, and in some cases I've actually used see here flow references, and in some cases I've used the request call. Okay. And in if I show you the configurations of the request call, you will find out, see, it's taking the local host. If it's deployed to cloud hub, you will change this to 000. Okay. But since this is in local, you just simply set this. Okay. Create a configuration and you'll set this. If you right click on the API router, it will automatically generate this. Okay. And you provide that path to your actual implementation. Okay. And it will simply, what it'll do, it will deploy both, and it will be an internal call. Okay. Through this request. So it's also another neat way of doing it. And here, what am I doing? Since in the behavior, I've set the payload here. In the body, I'll simply pass the payload. And it'll act as if I'm calling that API using an HTTP request payload. And we'll check the response. Okay. Next, another content that I added was, error scenarios. How do we cater to error scenarios? Okay. So let's mock the APIKit router. Okay. In the main flow. And what do we do? Rather than selecting any of these, we just simply click on error and we pass an error type. Now, here also I have parameterized the whole thing. I'll show you how I've parameterized it. So this is the parameterized YAML. Okay. This is the parameterized YAML, and in each case, it will pick up all of the error type is what for bad request, the status code, HTTP, all of these things, right? So I will cover all of these errors in one test. Okay. So this was a very neat use case to test out. In the previous one, it was like a small use case. This is like a much more real life, much more efficient use case. So you assign all of these error types, status code, and message, right? And it will parameterize it. Be sure the parameter names should be exactly similar for all of them, otherwise parsing will fail. Okay. These set of parameters, I mean, just the key names must be same across all of the parameters. Okay. Now, what am I doing here? I'm mocking that. Okay. And by mocking, what I'm saying is, when you get the API kit router, don't do anything, throw an error. Okay. And what error will you throw? Error type. So let's go back to this. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 8, right? Eight, yeah. So it will throw eight different types of error types, right? And that way I'll be able to test all of my error handlers, right? So let me go back very quickly. Uh, Okay, now when the error will be thrown, this flow will be errored out, right? You need to have an on error continue here. Otherwise, what will happen? It will simply error out and the whole test suite will be failed. So you need to put an on error continue so that the control passes on to validation. This is a must. Okay. Next, what do? We kind of set the response by when so because we are in this so this is parsed like into eight different elements, right? And the scope is when you're dealing with bad requests, the scope is only till here. Okay. So when the error type bad request is raised, if you call for dollar dot status code, it will return 400. Okay. It will not return any of the other kinds because the scope is right now only within this group. Okay. So here, what we'll do, since I'm setting the status code here, if this guy raised a bad request, here the status code will be 400, okay? And the message will be whatever is the message stored in the parameterization. So it's bad request error probably. Now, finally, what do? We actually check the HTTP status, okay, against the one that we are setting here from the parameterized file, right? And that is how we match it. We can also match the response message also if you want. So this is the response message. This is where the actual error message comes in. And with that, I'm also checking the parameterized value, and that is there. This is how in one go you can check this whole all of these error handlers in one go. Okay, right? This takes care of your compliance, maybe not so much for your functional requirements, because for each case you can have like separate, like suppose in bad request, in one case it will be like field one did not conform to some enumeration, and in other case it will be field two missing. You have to create functional test cases for that then separately. Okay, you'll have to parameterize it in such a way that it can take care of both, right? Actually, I did a little bit of that. I put two namespaces over here, and I tried to handle it, and it worked also. This also worked. Okay. So yeah, you can do all of those things with this. Finally, in a couple of minutes, I'll just explain the batch step. Okay, because this is asynchronous, and this is quite interesting. So in the batch scope, what happens is you have this whole batch thing, right? So I'm fetching all the country details. So all 100 countries are here. I'm setting it as the payload here and passing that payload, all 100 countries list into this batch. The job of this guy is to simply take the region and make it uppercase, right? That's it. Simple thing. How do you test it? So you put the whole thing, this whole flow inside, a flow reference here, right? And then what do is you do a spy. What does spy do? In spy, you can ask it which processor to spy on actually. Okay. So where is it? Where is it? Where is it? Sorry about that. Too many tabs open. Um, right. So you're spying on this guy. Okay. So what happens before and what happens after? Okay. So what am I doing here? In the test flow, in the spy, I am trying to check what happens before that batch step. Okay. So successful records is one of the variables generated by the batch after it's over in the completion stage, right? So before you call and before you call anything, successful records will always be null. There will be no values because you've just called it, right? There's no successful values here. So you check the null, whether it's null or not. Okay, it should be null. And after that, because I know my code has like 100 countries will be fetched. The number of times, I mean, the successful record basically for all the entirety of batch, the total successful record count should ideally be 100, right? That is what I know, but this is after. Okay, so spy, what it does is It checks before and it checks the after. So spy is one of the few things which is like a black box testing, right? You don't care what is inside, okay? You just care what happens before and what happens after. You don't care what is it that you're spying. Okay, you'll treat whatever you're spying as a black box. Okay. Now, this and another thing that we need to do is verify call. So if you look at, okay, let me go back here. If you look at here, there is a transform message, right? So ideally, if there are 100 countries and you need to make the region uppercase, you have to do it 100 times. So this transform message has to be called 100 times, right? How do you test that? You go to this here. There is something called verify call. In verify call, you provide that transform message. Please ensure you provide the doc ID here. Doc ID is the only unique identifier of each processor. Okay, don't go by the name. Definitely put the doc ID. Okay, and here, what you do, you simply check the number of processor executions, mark the comparison as is equal, and make it 100 because it has to be called 100 times. Okay. This way, what will happen? It will check all of those parameters. Another thing, this is a synchronous call. 100 times might have like, you know what? It might divide the whole batch block into like 4 units or 5 units. How do you know? So you'll have to wait for that batch to be over. So for that, definitely keep the sleep. This is also another, I think, MUnit tool only. This sleep, yes. And I've kept 500 because it's just 100 records. But be sure, check how much time your batch takes and put that time here so that otherwise MUnits will time out. So you need to make this thread, ask this thread to sleep till the batch is over. Okay. With that, I come to the end of this demonstration of MUnits and special cases. Sorry, not this one. My bad. Okay.
Yeah, so do we have any question from the participants? Let's take this.